Hello everyone, welcome to the Civil Study World. I'm Dr. Nimisha. So today we have the second part of Staad Pro series, analysis of simple beam carrying a point load. So let's move on to that. Let's go through the question once. Analyze an RCC beam of dimension 230 by 400 mm as shown below. The beam is made of M25 concrete and it is loaded with a point load of 10 kN at the midspan. So we have a beam of length 4 meter and it is hinge supported at ends A and B. It is loaded with 10 kilonewton point load at the midspan. So now we have to model this beam in our Staad Pro software. Once you start with the Staad Pro software, you will get a window like this. So here you can start with new project. Here I will select the option plane because I need to model a 2D beam. Here I will give the file name as beam1 and I have selected the location of my project. Then the length unit is meter and force unit is kilonewton. Then click on next. Then here I'll select the add beam option itself. Then you can click on to finish. So this is the main user interface of Staad Pro. We have various view options here. You can see this is the front view and this is the view from the back side and this is the left side view and right side view, then top view, bottom view, and this is the isometric view. You can see here your grid lines are in the isometric view. So here this is in the isometric view. So for the convenience of generating a structure, I will select front view. See, now my grid lines are changed to the front view. We have various view options here. You can see this is the front view and this is the view from the back side and this is the left side view and right side view, then top view, bottom view, and this is the isometric view. You can see here your grid lines are in the isometric view. So here this is in the isometric view. So for the convenience of generating a structure, I will select front view. See, now my grid lines are changed to the front view. So now I can easily draw my beam structure. Here I have a beam of 4 meter length. So let's see how we will draw a 4 meter length beam. We have various options to model a structure. Either you can use the snap node option. Let's check it first. Here you can just on this snap node icon. So your cursor will change like this. So here you can draw your structure with this like this. See, like this we can model. So this is an easy method, I think. And otherwise, there is another method also. You can generate nodes. That is by adding the coordinate of each node, you can generate the nodes and later you can join these nodes by using add beam option. This is the add beam option. You can use this option to join different nodes. That is another modeling technique used in Staad Pro. Now let's model the beam given in the question. So it's a beam of length 4 meter. It is having a load 10 kilonewton at the midspan. So we can model the beam either as a single member or as a two members because we need to apply a load of 10 kilonewton at the midpoint. So now I'll model the beam as two members with length 2 meter. So let's start with the snap node option. So my cursor will look like this. I will start from the origin. This is an auto save option, so you can click on yes, save. So you can start from here. Then so first member will be of 2 meter length. So click on here. Then again I have a 2 meter length member. Again click on. Then now press escape. So now you have two members of 2 meter length each. Now in this members you can apply your material properties, member properties, the sections, support, loads, everything you have to assign. Then it will look like your beam. So now let's see how we can do that. In order to apply all those properties, you can go to the option General. Now we have various options, materials, loads and definitions, support, specifications, then properties. So let's see it one by one. First, we will assign the material. So if you click on the material, you will get a window like this. Here you have to take concrete because the material is concrete, M25 concrete. So click on concrete and you can edit it. Edit. So here you can apply the compressive strength of concrete. So it is M25 concrete. So the compressive strength FCU will be 25,000 kilonewton per meter square. Click on OK. Now you have to assign. You created a material concrete of M25 grade. Now you have to assign that material to the members. For that, you can use assign to view option. If you use assign to view option, the material will get assigned to all the members of the structure. Suppose if you want to assign this material to a particular member of the structure, then you can use cursor to assign. So if you use cursor to assign, you can click on that particular member so that it will get assigned to that member only. So now I will use assign to view option because all the members, we have only 2 members. So these 2 members are of M25 grade concrete only. So I will use assign to view option. Click on assign. So assignment method you have chosen is assign to view. Do you want to proceed? Yes. Now the concrete material is assigned. M25 grade concrete is assigned to the members. Now let's move on to the properties. So you will get a window like this. Here you can click on define. I have to define my sections. Define. Here you have various options like circle, rectangle, T. So from this you can select the type of your structure, the shape of the members. So we have a rectangular section. I will use rectangle 230 by 400 mm. So here the width ZD is 230 and YD is 400 mm. So I will assign this is in meter. So I will use 0.23 for ZD and YD is 0.4. So here the material is concrete. Now click on add. So now you have the section here. Click on close. Now you have to assign. You have created a section. Okay. Now you have to assign this section. How you will assign is you can use assign to view option, or else you can use cursor to assign option, or else here the members are selected. So again we got another option that assign to selected beams. So that also you can use. I will use assign to view only because all members are of this section only. Assign. Yes. Now my section is assigned. So if you want to see your section whether it is assigned or not, if you want to check it, then you can use this option 3D rendered view. So this is the view. You can click here. This is 3D rendered view. So this is your beam. See, this is of 230 by 400 mm. And we have 2 members of 2 meter length each. So like this you can check whether member properties assigned to all the members or not. If you are doing multi-storied building or something like that, so you'll be having number of members. So there's a chance to miss some sections or members. So you can check like this. Okay, we can close this. Now next step is support. We have to assign the support. So here we have hinge support at both ends. So we can create hinge support. We can create here. Create. We have hinge support is here named as pinned. Okay, fixed, we have fixed, then pinned, fixed, but we will use for all the support. Okay, so these options we can see it later. So now we will assign pinned support. So for pinned support, you know, this fx, fi and fz values are restrained. Okay, so means there will be reaction in these directions. So in the pinned support we have reactions in horizontal and vertical direction. Because it's a 2D structure, we don't need to consider this fz. So fx and fi will be restrained, so it will generate reaction in that direction, and it will rotate. Pin support will rotate, so we are not restraining the moments, it will rotate it. Now you can add this. So I have a support, pin support here. Now I need to assign this support to the nodes. Okay, so for that, first I need to see my nodes. Here I'm not able to see the nodes. For that you can use this node cursor. This is the node cursor and this is the beam cursor. Okay, with beam cursor you can select your beam, and with node cursor you can select your nodes. You can drag and select here. You are having 3 nodes at the ends and at the middle. So you have to assign the support to the end nodes. I'll click on here and use cursor to assign option. I will use assign. Click on the end nodes. Yes. Now you have assigned your supports. The next step is the load assignment. So for that you have to create your load. Now in order to generate the load cases, or in order to create the various loading conditions, we have to go to the option loads and definition. If you click on this, you will get a window like this. Here you can see the definition, load case details, then load envelope. Here normally in this question we have a load of 10 kilonewton applied at the middle point of the beam. So we need only 2 cases, dead load and live load. If you have other load cases like wind loads, you have to define that load first. So we will see it in our next videos, in the upcoming videos. So first let's see the simple cases. First we have to create load cases because we have to assign so each of these loads as different cases. Dead load as one case and live load as another case. So we'll create the load case first. Click on load case details, then click on add. Now you will get the window like this. Here you can select the loading type. First, this is the first load case. So loading type I'm selecting as dead load. Here you can rename as dead load. Now click on add. Again, so load case is created here, you can see. Now I will generate another load case, live load, add. Now again another load case is created. Now you can generate a combination also, define combination. Either you can use auto load combination so that it will generate the load combination according to the code. You can select code from here, and with this you can generate auto load combination based on the code, or else you can define the combination. I will use the define combination command. Here I have 2 load cases, dead load and live load. So the default factor will be 1.5 based on the code. So 1.5 dead load plus 1.5 live load, that case I will use. See how I assigned the load combinations. You have to enter the factor and you have to here available load cases will be shown. So you have to select these two load cases. Okay, now you can click on add, close. So I have three load cases here: dead load, live load, and combination load case. So now I will generate this different loads in the corresponding load cases. So first I will take the dead load case and add. Now you can assign the sulfate here. So we have the direction y as in the upward direction. So you can give the factor -1. Means it will take the sulfate. It's in the negative direction of gravity. So because y is up, so we have to give -1, and I will add this. Now close. You can assign the sulfate to all your members. So I will use assign to view option. Click on assign. Yes. So the sulfate is assigned. You can see the icon is changed to the green color. Initially it was not like that. Now it is changed to a green color. Now we can generate live load. Click on live load, add. Now you have a middle node here. We have three nodes, two at the ends and one at the middle. So you can use the nodal load. You can apply the load as a nodal load, or suppose if you have not created a node at the middle, suppose you have generated the structure as a single member, then you have to use the member load. Okay. Now I have one middle load, so I will go for nodal load option. So here you can input your load value. I have 10 kilonewton load in the y direction. So here -10. I will input -10 kilonewton. Okay. Now I will add this. Then close. Now you can see I have a load here in the y direction. So now I want to assign it. Click on the load. Now you can use cursor to assign option, because I need to assign this load to that particular node only. So I will use cursor to assign option, then click on assign, then click on the particular node. Now you have assigned the load. See, you're not able to see the end of this arrow. So if you want to change, or if you want to see it, if you want to rescale it, you can go for the option labels. For that, you can right click, and here you have labels. Here you can see various options. You can use load values. Click on load values, then it will display the load values, and you can go to scale. Okay, so you can change the scale of this members, and also, I mean, not members, the results. You can see the point force, distance, distributed force, point moment. So these are the different results you may get from the analysis, and also this load also we can change. So in order to view that change while changing this scale here, you have to click on apply immediately. So don't forget this option, otherwise you won't be able to see the change here. So for that, in order to see that change simultaneously, you have to click on here. Now you can change the point force. It's not changing, so yeah. Now it has changed. Now you can see the load. We have okay labels. So we have checked this load value, so it displayed the load value also. Now you can click on apply. Okay. So This is the beam structure given in the question. Now, the final step is the analysis. For that, you have to go to the commands, analysis, perform analysis. Here you have various printing options. Now I will select no print only, because if you select no print, it won't print the output, this results, analysis results in the output file, but you can see it in the post processing mode. Either you can select that, or you can select accordingly. You can print the load data, or if you want to print every results, you can take all option. So I will choose no print only. Click on OK. Then click on analyze, run analysis. Save. So the analysis is complete now. Now you can go to view output file in order to view your results printed in output file. So this is the Staad output viewer. In this, you'll get all your results printed if you use all print option during perform analysis. So here I have taken no print option, so results will not be printed in this file. Only the job details and the material properties, or the details of the structure will be printed. Here you can see the job details. These are the default conditions because I didn't enter any new job information here. And the unit, then join coordinates, member incidences, then material properties, section properties, support, then loading conditions. All are printed here first. Then if you have taken the options to print all your results, then you'll get the results like bending moment, shear force, axial force. So all those values will be printed in between this. So now we'll see the results in the post processing mode. So we can take the post processing. So this is the post processing mode. You can click on here and you'll get a window named as result setup. So here you can see the load cases you have created. Dead load, live load, and combination load case 3 is there. So these are selected. So if these loading conditions are available here in this section, then you have to select all these loading conditions to this side. Then click on to apply. Then OK. Here you can see the different loading conditions: dead load, live load, then combination load case, then envelope. So from here you can select the loading condition you want. You want to see the results, you will get the results corresponding to that loading condition. So I will choose live load here, and if you want deflection, you have to click on this icon, deflection. Then this is MZ is the bending moment, then Fy is the shear force, and if you want any axial force, then you have to click on to Fx, axial force. This is the shear force. So now I have click on a deflection. Then if you want to change the scale again, you have to right click on labels, then scale, then apply immediately. Then you can change the scale of displacement. You see this changing. Yes. Okay. Now in order to view the maximum deflection, you have to click on to the results, view value, then beam results. Here you can see the displacement. Click on maximum resultant, then click on annotate, close. So this is the maximum deflection value corresponding to the live load condition. Then if you need deflection corresponding to the combination load case, then you can select the load case. Here you can see the result. Maximum deflection is 1.188 mm. Now if you want to view the bending moment results, then place off this deflection icon and click on bending moment MZ. Then you will get the bending moment diagram. To get the values displayed, click on to results, view value, then beam results, click on maximum, or if you want the bending moment at the ends, you can click on here, and to get the bending moment at the midpoint, you can click on here. So I'll click on maximum now, then click on annotate. Okay, close. So this is the bending moment, maximum bending moment corresponding to the combination load case. So I'll check it for live load case also. So this is the maximum bending moment. Now if you need the shear force, then click on here and please off the bending moment diagram, and this is the shear force diagram you can see, and you can go to results, view value to display the values, beam results, then shear force. Click on maximum and check this, annotate. So this is the shear force diagram. Likewise, you can see all the results in the post-processing mode. We have seen the analysis of a simple beam loaded with a point load at the midpoint. If you find this video informative, please like, share and subscribe. Thank you.